10.4 also includes an examination of common tangents. A common internal tangent falls between the two circles. It can fall in either direction. That's an internal tangent, as well as that line there. And the tangent will intersect each circle at only one point. Common external tangents fall outside the circle. I like to cook, so that I think of them as like the kitchen countertop or a tabletop, where you could have two round foods like a tomato and a cantaloupe, or an apple and a cantaloupe, sitting on top. And if they're both sitting on top of the flat surface, then that's an external tangent. Here are more examples of an external tangent. Now, even though that's on top of the circles, you could visualize flipping that around so that it would be a tabletop. This is also the external tangent. Let's look at an algebra-based common internal tangent problem. Two circles, x and y, with radii 8 and 9, respectively, are 27 units apart. Find the length of the common internal tangent. The common internal tangent is labeled AB. You always need a diagram to solve these problems. I'm going to begin by drawing the radius of the larger circle. Remember that a radius drawn to a point of tangency is perpendicular. Then I want to use the internal tangent and the large radius as two sides of a rectangle. So now I'm going to continue my rectangle, drawing the side that's parallel to AB, then drawing the side that's parallel to the large radius. And notice I've extended it to meet the center of the other circle. So these are all right angles. They told me that the radius of the smaller circle was 8, the radius of the larger circle was 9. Since I drew this as a rectangle, opposite sides are both parallel and congruent, I know that's 9. That makes this distance 17. I don't know what this measure is. That's the common internal tangent, which is the measure that I'm looking for. I do know, however, that the centers of the circle are 27 units apart. So now I've created a right triangle. Now I'm just going to use the Pythagorean theorem to solve the right triangle. So I have the unknown length squared plus the leg 17 squared equal to 27 squared. That doesn't look like a triple, and there isn't any common factor between 17 and 27, so I'm going to end up just using the Pythagorean theorem for this. Then I'm going to subtract and get now when I take the square root of each side, I get question mark equals the square root of 440, which is equal to the square root of 4 times the square root of 110. The square root of 4 is 2, and 110 is simplified. So that 2 root 110 is the length of the common internal tangent, AB. To solve a common external tangent, we are given a circle with radius 8 is externally tangent to a circle with radius 18. Find the length of the common external tangent, again labeled AB. They've drawn both radii in for me as well as the external tangent. What I'm going to start with is the rectangle again. So I'm going to connect so that I have a rectangle here. Then I know that these two sides are congruent, so that's 8. And if the whole thing is 18, that makes that part 10. This is a fun one because they don't give you any additional information. But you are told that the circles are tangent. Bear in mind that all radii of the same circle are congruent, so that measure is 18, that measure is 8, which makes this whole side here 26. Now, this was a right angle, so this is a right angle because those are parallel. So this right here is my right triangle. And the length that I need to find is right there. So one leg squared, which is x, plus the other leg squared, that leg is 10, will equal the hypotenuse squared, which is 26. So x squared plus 100 equals 676. Subtract 100 from each side. And x would be, if you were just square rooting and solving, positive or negative. But since I'm talking about a length, it's just going to be the positive, 24, in this case, centimeters.